Hi everyone, welcome back to my channel. This is Mr. Bodejas, your online math teacher. In today's video, you will learn the center radius form. Let's start with the definition of a circle. Circle is the set of all points in a plane equidistant from a fixed point called the center. We have the set of all points here that surrounds the fixed point, which is the center, and the distance from that center to any point on the circle is equidistant. When I say equidistant, they have the same distance. The center of the circle can be at the origin or at 0, 0, or it can be at HK. When I say HK, the center is not at the origin. Radius is the fixed distance from the center to the circumference of the circle. For example, here we have the center is at HK, and the distance from the center, which is we have point P to point Q, which has the coordinates of X and Y. The distance is what we called the radius. Next, we have the standard form of equation of a circle. It is also known as center radius form. A circle with center at HK and a radius of r has an equation of the square of x minus h plus the square of y minus k is equal to the square of r. This equation is derived from the distance formula. For example, we have a circle here with center at HK and a point which has the coordinates of x and y. Using the distance formula, we can get the distance from P to Q, which is the radius. So using the distance formula, we have r is equal to the square root of x minus h squared plus y minus k squared. Then, taking the square of both sides, we have r squared is equal to the square of x minus h plus the square of y minus k. Again, the equation of a center radius form or the standard form is derived from the distance formula. Standard form of equation of a circle with center at the origin. If a circle has a center at the origin, which has the coordinates 0, 0, and has a radius of r, the distance or the equation becomes x squared plus y squared is equal to r squared because h and k here is 0, 0. So we have this equation x squared plus y squared is equal to r squared. Again, this equation is if we have the center at the origin. Let's try some examples about the equation of a circle. Number 1, find the equation of the circle with center at the origin and a radius of 6 units. To solve this, we have to identify the values of h and k. Since the center is at the origin, the value for h and k are both equal to 0. So we have to apply the equation of a circle centered at the origin and replacing the radius or r by 6. The equation of a circle with center at the origin is x squared plus y squared is equal to r squared. Just substitute the value of r, which is 6. Then simplify. We have 6 squared That is 6 times 6, we have 36. Therefore, the equation of the circle is x squared plus y squared is equal to 36. Example number 2. Write an equation of the circle with center at 0, -9 and a radius of 5 units. As you can observe, the center is not at the origin anymore, meaning there is a value for h and k, which is not 0, 0. The values for h, k, and r are the following. We have the center as coordinates of 0, -9. So we have h is equal to 0 and k is -9. And the radius is 5 units. Now apply the center radius form of an equation of a circle, which is we have the square of x minus h plus the square of y minus k is equal to the square of the radius. Our h is equal to 0. Substitute h, we have 0. Then k, -9. R is 5. X minus 0 is just x, then copy squared. And negative times negative is positive. So you have y plus 9 squared is equal to 5 squared is 5 times 5, and we have 25. Therefore, the equation of the circle is x squared plus the square of y plus 9 is equal to 25. And that's all for today. And now I want you to solve these two problems here under individual practice. And please do comment your answers so that I can check if your answers are correct. Number 1, write the standard equation of the circle shown on the right. Just write the standard equation. Number 2, write the standard equation of a circle with center at -2, 8, and the diameter of 4.2 units. And that's all for today. Thank you for watching.